Okay, so many people have asked me questions about this diagram that I wanted to record an explanation of. It has a lot of information, but it's very useful. So what we're showing here is basically everything that might happen to certain proteins from the point where they're transcribed from DNA in the nucleus all the way through where they're going to end up in various organelles. So here again we have the genome in the nucleus, of course. We have transcription. Okay, that part's easy. We have mRNA. Before the mRNA leaves the nucleus, it needs to be matured, which means that it's going to have splicing, capping, and polyadenylation. And then it has proteins that bind the 5' cap, proteins that bind the exon-exon junctions, and proteins that bind the poly-A tail. Okay, so all those proteins need to be in place before this molecule leaves the nucleus through a nuclear pore. Then we have mRNA out in the cytoplasm. In the cytoplasm, this mRNA is going to switch out the protein that's bound to the 5' cap, and now we're going to have initiation factors bound to that 5' cap instead of the 5' cap binding protein that was used to get out of this nuclear pore. That's also in our textbook. So then we have the association of the mRNA with the small ribosomal subunit as well as methionine tRNA. If you don't remember the rest of the initiation process for translation, I suggest you go back and review that. And once we've started translation in the cytoplasm, if the mRNA encodes an endoplasmic reticulum localization sequence, then we're going to bring the entire complex over there